Harvard professor publishes controversial paper questioning whether 3I-ATLAS could be artificial technology. The astronomical community is fracturing over Dr. Avi Loeb's latest research paper, which presents mathematical analysis suggesting 3I-ATLAS displays characteristics that challenge conventional models of natural interstellar objects, raising questions that most scientists aren't willing to ask publicly. The trajectory analysis reveals something genuinely unsettling. 3I-ATLAS approaches Venus, Mars, and Jupiter with a combined probability of just 0.005% for random occurrence. When you add its retrograde motion within 5 degrees of our ecliptic plane, the mathematical likelihood of natural formation drops to levels that make statisticians uncomfortable. The timing creates an additional mystery that nobody wants to discuss. 3I-ATLAS entered our solar system approximately 8,000 years ago, during the exact period when human civilization transitioned from prehistoric to historic societies, developing writing, agriculture, and permanent settlements. The correlation might be meaningless, or it might represent surveillance timing that spans millennia. NASA's James Webb Space Telescope has detected chemical signatures that don't match any known natural processes. The carbon dioxide to water ratio of 8:1 represents the highest ever recorded in any comet, 6 standard deviations above typical values, suggesting formation under conditions that don't exist in contemporary stellar environments. But here's what's driving the scientific establishment to desperate measures to discredit anyone who asks these questions. In less than 70 days, 3I-ATLAS will pass behind our Sun, completely hidden from ground-based observation for 6 weeks, during what orbital mechanics call the optimal window for solar O-berth maneuvers that could completely alter its trajectory while remaining undetectable to Earth-based monitoring systems. The institutional response reveals how unprepared the scientific community is for discoveries that challenge fundamental assumptions about our cosmic isolation. Rather than investigating these anomalies objectively, establishment astronomers are mounting personal attacks against researchers who dare suggest that 3I-ATLAS might represent something unprecedented in human experience. Tonight, we're going to examine the evidence that's creating this scientific crisis, explore why the mathematical probabilities demand serious investigation, regardless of how uncomfortable the implications might be, and discover what the December re-emergence of 3I-ATLAS might reveal about humanity's place in a universe that could be far stranger and more dangerous than our optimistic assumptions about cosmic neighbours and interstellar exploration. Before we begin, don't forget to like, subscribe, and hit the new hype button, but only if you genuinely enjoy calm science to relax with or fall asleep to. And tell me where you're listening from and what time it is there. Oh, and one more thing. For my earliest supporters, I'm opening a lifetime ad-free access to my entire Science for Sleep library, every previous and upcoming 2-hour episode in MP3 form, yours forever, for just $19.99. This one-time thank you won't last, so claim it now through the link in my bio. Harvard's Avi Loeb didn't build his reputation on wild speculation. This is the former chair of Harvard's astronomy department, the founding director of the Black Hole Initiative, a scientist who's published over 800 peer-reviewed papers. When someone of his stature risks everything on a theory this explosive that the scientific world pays attention, even when they're horrified by what he's suggesting. Loeb's paper, co-authored with researchers from the Initiative for Interstellar Studies, doesn't just propose that 3I-ATLAS could be artificial, it specifically invokes the dark forest hypothesis, the solution to Fermi's paradox that suggests the universe is full of advanced civilizations that remain hidden because revealing yourself means destruction. In this scenario, any civilization that broadcasts its existence or sends out probes becomes a target for preemptive annihilation. The theory emerged from Liu Cixin's science fiction trilogy, but its scientific logic is chillingly sound. If resources are finite and intentions unknown, the safest strategy for any civilization is to eliminate potential threats before they become actual threats. Earth has been broadcasting radio signals into space for over a century. We've sent out golden records on Voyager spacecraft, deliberately announcing our existence to anyone who might intercept them. According to the dark forest hypothesis, we've been ringing the dinner bell for our own extinction. 3I-ATLAS entered the outer boundary of our solar system approximately 8,000 years ago, based on its current velocity. 8,000 years ago, human civilization was just beginning to document history, developing writing systems, building the first cities. The timing feels less like coincidence and more like surveillance, as if something has been watching our technological development and decided to investigate more closely as we approach spacefaring capability. Loeb's analysis focuses on what he calls the object's anomalous characteristics that distinguish it from normal comets or asteroids. First, its size. Early estimates suggested a diameter approaching 20 kilometers, making it potentially the largest interstellar object ever detected. Objects this size should be extraordinarily rare in interstellar space. For every 20-kilometer interloper, we should have detected millions of smaller ones, yet 3I-ATLAS stands alone in this size category among confirmed interstellar visitors. Second, its brightness pattern suggests something unusual about its composition or structure. Unlike typical comets, which become visible primarily through reflected sunlight from dust clouds, 3I-ATLAS appears to dominate the reflected light itself. This implies either an unusually reflective surface or a compact structure that doesn't fit standard cometry models. Third, and most intriguingly for Loeb's hypothesis, 3I-ATLAS began showing cometry activity, including gas and dust emission, at approximately 4.4 astronomical units from the Sun. Most comets don't activate until they're much closer, within Jupiter's orbit. This early activation could indicate either unusual ice composition or, according to Loeb, the deliberate venting of gases to maintain the appearance of a natural comet. The spectroscopic evidence adds another layer to the mystery. NASA's James Webb Space Telescope detected an unprecedented carbon dioxide to water ratio in 3I-ATLAS's coma, 8:1, the highest ever recorded in any comet. This extreme ratio suggests formation conditions unlike anything in our solar system, potentially indicating an origin from a stellar environment with radically different chemistry. From a pure surveillance perspective, 3I-ATLAS's trajectory offers remarkable advantages for an intelligence-gathering mission. Its path will bring it relatively close to three major planets, Venus, Mars, and Jupiter, potentially allowing for the deployment of smaller reconnaissance devices or detailed gravitational analysis of these worlds. More importantly, its closest approach to the Sun will occur when Earth is on the opposite side of our star, meaning the object will be completely hidden from ground-based telescopes for several crucial weeks. Loeb argues this hidden period represents a perfect opportunity for what spacecraft engineers call a solar obirth maneuver, using the Sun's gravity to change velocity and trajectory with minimal energy expenditure. If 3I-ATLAS were to slow down during this hidden period, it could fall into a bound solar orbit, potentially setting up a later approach to Earth. The optimal timing for such a maneuver occurs precisely when the object would be invisible to our detection systems. The scientific community's reaction has been swift and harsh. Chris Lintott, an astronomer at Oxford University who helped simulate 3I-ATLAS's galactic origins, called Loeb's suggestions nonsense on stilts and an insult to the exciting work going on to understand this object. NASA's Tom Statler was more diplomatic but equally dismissive, stating that 3I-ATLAS looks like a comet as comet things and very strongly resembles the comets that we know. Yet Loeb's defenders point out that this isn't pure speculation. The paper includes detailed orbital mechanics calculations, probability analyses, and specific predictions that could be tested. If 3I-ATLAS continues on its current trajectory without deviation, behaving exactly like previous interstellar comets, the artificial hypothesis would be effectively disproven. However, if anomalous accelerations or trajectory changes are detected, particularly during its hidden period behind the Sun, the debate could shift dramatically. The timing of these observations creates additional pressure on the astronomical community. 3I-ATLAS will reach its closest approach to the Sun on October 30th, disappearing behind the solar glare from Earth's perspective. It won't re-emerge until early December, giving astronomers only a narrow window to detect any evidence of artificial behavior. During this hidden period, several space-based missions will attempt to maintain observation. ESA's Mars Express and ExoMars Trace Gas Orbiter will observe the comet during its closest approach to Mars in early October. The Jupiter Icy Moons Explorer currently en route to the outer solar system, may have the best positioned instruments to detect any unusual activity during 3I-ATLAS's perihelion passage. The implications of Loeb's hypothesis extend far beyond astronomy. If confirmed, the discovery of artificial interstellar objects would represent the first evidence of extraterrestrial intelligence, fundamentally altering humanity's understanding of our place in the universe. More disturbingly, if 3I-ATLAS represents reconnaissance for a civilization operating under dark forest principles, its presence could indicate that our long period of cosmic anonymity is ending. The paper explicitly warns that the consequences, should the hypothesis turn out to be correct, could potentially be dire for humanity, and would possibly require defensive measures to be undertaken, though these might prove futile. This isn't academic speculation anymore. It's a call for planetary defense planning against potentially superior technology. Current human space defense capabilities are designed primarily for asteroids and natural disasters, not for artificial objects with unknown capabilities and potentially hostile intentions. Our most advanced spacecraft move at speeds measured in tens of kilometers per second. 3I-ATLAS travels at over 60 kilometers per second, faster than anything we've ever built. Even our detection systems weren't designed for this scenario. The ATLAS survey that discovered 3I-ATLAS was built to track potentially hazardous asteroids, not to identify artificial objects disguised as natural phenomena. If hostile civilizations are indeed using stealth technology to approach Earth, our current monitoring networks might miss dozens of similar objects. The dark forest theory gains additional credibility when we consider the broader context of interstellar object detection. 3I-ATLAS represents only the third confirmed visitor from beyond our solar system, following Oumuamua in 2017 and Borisov in 2019. Each of these objects has displayed characteristics that challenge conventional understanding of natural celestial mechanics. Oumuamua's cigar-like shape and unexplained acceleration as it departed our solar system sparked similar speculation about artificial origins. Loeb himself published papers suggesting Oumuamua could have been a light sail, a thin artificial structure designed to catch stellar radiation for propulsion. The scientific establishment largely rejected this interpretation, favouring explanations involving outgassing from hidden ice deposits. Now, with 3I-ATLAS, we see patterns repeating: another interstellar visitor with anomalous properties, another trajectory that seems almost too convenient to be random, another opportunity for the scientific community to confront the possibility that we're not alone in the galaxy. The statistical argument becomes even more compelling when we consider the rarity of interstellar objects in general. Based on current detection capabilities and observation time, astronomers estimate that large interstellar objects should pass through our solar system perhaps once every few decades, yet we've now detected 3 in less than 8 years, all during the period when human space technology has advanced enough to potentially pose an interstellar threat. This clustering could represent natural statistical variation, or it could indicate increased surveillance as Earth's technological capabilities approach critical thresholds. Our first spacecraft reached interstellar space in 2012 when Voyager 1 crossed the heliopause. Our most advanced propulsion concepts could theoretically reach nearby star systems within a century or two. From an external perspective, humanity might appear to be approaching the threshold of becoming a spacefaring, potentially threatening civilization. Loeb's paper raises uncomfortable questions about the assumptions underlying current search for extraterrestrial intelligence efforts. SETI has spent decades listening for radio signals from distant civilizations, operating under the assumption that advanced species would want to communicate. The dark forest hypothesis suggests exactly the opposite, that successful civilizations remain silent and eliminate potential threats before they can develop. If this interpretation is correct, then our century of radio broadcasts, our deliberate attempts to signal our presence through projects like Arecibo's interstellar messages, and our plans for more powerful communication arrays might represent existential mistakes. We've been shouting our location into what might be a galaxy full of hidden predators. The timing of 3I-ATLAS's approach, reaching perihelion just as global tensions on Earth are escalating, adds another unsettling dimension to Loeb's analysis. A reconnaissance mission would want to assess not just our technological capabilities, but our social stability, our likelihood of developing unified space-based defenses, a potential for internal conflict that might delay outward expansion. Current geopolitical conditions suggest a species on the verge of either breakthrough or breakdown, exactly the sort of transition period when external monitoring might intensify. Space agencies around the world are developing independent lunar bases, Mars colonization plans, and asteroid mining capabilities. Within decades, human presence in space could become self-sustaining and potentially threatening to other civilizations. The December emergence of 3I-ATLAS from behind the Sun will provide the first real test of Loeb's hypothesis. If the object continues on its predicted trajectory without deviation, the artificial intelligence theory loses much of its credibility. However, if any anomalous behavior is detected, if trajectory changes occur that can't be explained by natural gravitational effects, then the scientific community will face an unprecedented crisis. Ground-based telescopes around the world are already preparing for this crucial observation window. The European Southern Observatory's Very Large Telescope, the Keck Observatory in Hawaii, and radio telescope arrays across multiple continents will focus on 3I-ATLAS the moment it becomes visible again. Any deviation from predicted behavior will be detected within hours and analyzed by teams of experts looking for signs of artificial propulsion or course correction. The psychological impact of confirmation would be staggering. Humanity has never faced verified evidence of extraterrestrial intelligence, let alone potentially hostile intelligence. The social, religious, and political upheaval could be catastrophic, particularly if the evidence suggests we're being evaluated as a threat to be eliminated rather than welcomed as neighbours. Military strategists are already quietly discussing scenarios that were pure science fiction just months ago. How do you defend against technology that can cross interstellar space? How do you negotiate with entities whose first contact consists of reconnaissance rather than communication? How do you prepare civilian populations for the possibility that we're not the apex intelligence in our local galactic region? Chapter 2. The December Test. Hidden Maneuvers. The clock is ticking toward the most crucial astronomical observation in human history. On October 30th, 3I-ATLAS will disappear behind our Sun, vanishing from every ground-based telescope on Earth for approximately 6 weeks. When it emerges in early December, we'll discover whether Avi Loeb's terrifying hypothesis about alien reconnaissance has any basis in reality. This isn't just about academic debate anymore. Space agencies across 3 continents are quietly repositioning assets, reprogramming observation schedules, and preparing for what could be the first confirmed detection of extraterrestrial technology. The European Space Agency has already announced that both Mars Express and ExoMars Tracegas Orbiter will attempt continuous monitoring during 3I-ATLAS's closest approach to Mars on October 3rd, maintaining observation even as the object becomes invisible to Earth-based instruments. The physics of what happens during this hidden period are genuinely alarming from a defense perspective. When 3I-ATLAS swings behind the Sun, it will be travelling at over 150,000 miles per hour, carrying enormous kinetic energy that could be redirected using gravitational mechanics that human engineers are only beginning to understand. The solar obirth manoeuvre that Loeb describes isn't science fiction. It's established orbital mechanics used by NASA missions to achieve velocity changes impossible with onboard fuel alone. A spacecraft approaching the Sun builds tremendous speed, and firing engines at the precise moment of closest approach can produce velocity changes far exceeding what the same fuel burn would accomplish in deep space. For a natural comet, this closest approach represents simply the point of maximum heating and outgassing. For an artificial object, it represents the optimal moment to completely alter trajectory while remaining unobservable to the very civilization it might be targeting. Current calculations suggest that 3I-ATLAS could use this hidden period to decelerate sufficiently to fall into a bound solar orbit, potentially setting up approach trajectories to Earth that would be impossible to intercept with current technology. The mathematics are precise and disturbing. An object capable of interstellar travel would possess energy manipulation capabilities that make our most advanced spacecraft look like stone tools. Dr. Davide Farnokia, navigation engineer at NASA's Jet Propulsion Laboratory, has been studying 3I-ATLAS's trajectory since its discovery. While he remains skeptical of artificial origins, his calculations confirm the technical feasibility of course corrections during the solar flyby. The gravitational environment near the Sun allows for velocity changes that would require enormous fuel expenditures anywhere else in the solar system, he explains. If something wanted to change course undetected, perihelion would be the ideal time. The observational challenge is unprecedented. Ground-based telescopes will be completely blind to 3I-ATLAS for the entire month of November. Even space-based instruments like Hubble and the James Webb Space Telescope will struggle to maintain observation through solar interference. Only missions positioned away from the Earth-Sun line will have any chance of detecting anomalous behavior. ESA's Jupiter Icy Moons, Explorer, currently travelling toward the outer solar system, may have the best-positioned instruments for crucial observations during 3I-ATLAS's perihelion passage. However, the probe is operating with reduced communication capabilities due to its distance from Earth, meaning any critical data might not reach ground controllers until February 2026. This communication delay creates additional strategic vulnerabilities that military planners are only beginning to understand. If 3I-ATLAS displays artificial behavior during its hidden passage, we might not learn about it until months after the fact, when any subsequent approach to Earth would be imminent and impossible to counter. The specific dates matter enormously for testing Loeb's hypothesis. His paper provides precise predictions about when artificial behavior would most likely occur. Between November 21st and December 5th represents the optimal window for undetected maneuvers, when solar interference would mask any propulsion signatures and trajectory changes would be attributed to gravitational effects rather than artificial propulsion. Loeb has gone further, specifying that if 3I-ATLAS were to approach Earth using solar obirth techniques, arrival would occur sometime between late November and early December 2025. This isn't vague speculation, it's a testable prediction with a clear timeline. Either 3I-ATLAS will appear where natural orbital mechanics predict, or it will deviate in ways that suggest artificial control. The international space community is preparing for both possibilities. NASA has quietly redirected several deep space network antennas to focus on the expected re-emergence zone. The European Space Agency is coordinating with ground-based observatories across multiple time zones to ensure continuous coverage when 3I-ATLAS becomes visible again. Radio telescope arrays are being programmed to listen for any artificial signals emanating from the object. If 3I-ATLAS is indeed a reconnaissance probe, it might attempt communication or data transmission when it believes it's unobservable to Earth-based instruments. The Arecibo successor projects, distributed radio telescope networks, and even amateur radio operators are being organized to scan the expected frequency ranges. The detection protocols themselves reveal how seriously space agencies are treating this possibility. Standard asteroid tracking focuses on position and velocity. The 3I-ATLAS observation campaign includes spectroscopic analysis for artificial materials, radar profiling for geometric regularity, and thermal imaging for heat signatures inconsistent with natural solar heating. Perhaps most tellingly, several space agencies have developed what they're calling rapid response protocols for anomalous detections. These procedures, never before needed in civilian space science, outline steps for immediate notification of defense departments and international space security organizations if 3I-ATLAS displays behavior that can't be explained by natural physics. The technical specifications for artificial detection are more sophisticated than most people realize. Natural comets display predictable thermal signatures based on solar heating patterns. Artificial objects might show heat distribution indicating internal power sources or electronic systems. Natural trajectories follow mathematical curves determined by gravitational physics. Artificial objects might display course corrections, acceleration changes, or orientation adjustments that suggest active control. Even the timing of potential observations carries strategic implications. If 3I-ATLAS were to approach Earth in late November or early December, it would coincide with reduced daylight hours in the Northern Hemisphere, when ground-based telescopes have longer observation windows, but also when many space agencies operate with reduced staffing during holiday periods. Military space tracking systems, normally focused on satellites and debris, are being reprogrammed to monitor for objects on unusual approach trajectories. The Space Force's Space Surveillance Network, typically used to track defunct satellites and space junk, now includes parameters for detecting artificial objects attempting atmospheric entry or close Earth approaches. The psychological preparation is perhaps more challenging than the technical preparation. Space agency personnel are receiving briefings on protocols for handling potential first contact scenarios, even though officially no one expects 3I-ATLAS to be anything other than a natural comet. These briefings cover everything from data classification procedures to media management strategies if anomalous behavior is detected. International coordination adds another layer of complexity. If 3I-ATLAS displays artificial characteristics, which nation or organization takes the lead in response? The object was discovered by a US-funded system, but it will be observed by telescopes around the world. Data sharing agreements that work fine for natural phenomena become problematic when dealing with potential extraterrestrial intelligence. The December reemergence timeline creates additional pressure because it coincides with budget planning seasons for most space agencies. If 3I-ATLAS proves to be natural, funding requests for enhanced interstellar object detection can proceed normally. If it proves artificial, space defense budgets could be revolutionized overnight, with implications for everything from NASA's Mars program to military satellite constellations. Amateur astronomers worldwide are also organizing for this critical observation period. Unlike professional observatories with fixed schedules and bureaucratic constraints, amateur networks can respond rapidly to unexpected developments. These distributed observation networks might provide the first real-time confirmation of anomalous behavior if 3I-ATLAS deviates from predicted trajectories. The stakes extend beyond scientific discovery into fundamental questions of planetary security and human survival. If Loeb is correct about the dark forest scenario, the December observations could determine whether humanity has been discovered by a civilization that views us as a threat to be eliminated rather than a species to be contacted. Current detection capabilities remain limited compared to the challenge of identifying artificial objects designed to appear natural. Our most advanced instruments were built to study genuine astronomical phenomena, not to pierce sophisticated camouflage systems that might be employed by technological civilizations millions of years more advanced than our own. The observation window when 3I-ATLAS reemerges will be brief and critical. Any evidence of artificial behavior will need to be detected, confirmed, and analysed within days or weeks before the object potentially disappears back into interstellar space forever. This creates enormous pressure on observation teams and analysis systems that weren't designed for such high-stakes, time-sensitive detection scenarios. The contingency planning reveals just how seriously this possibility is being taken behind closed doors. Several observatories have developed what they euphemistically call priority interrupt protocols that would immediately halt all other observations if 3I-ATLAS displays unexpected behavior. These protocols haven't been used since the search for potential asteroid impacts, and never for anything that might represent extraterrestrial intelligence. Ground-based radar systems are being calibrated to detect structural irregularities that might indicate artificial construction. Natural space objects display rough, irregular surfaces created by billions of years of cosmic bombardment. Artificial objects might show geometric patterns, smooth surfaces, or internal structures that would be visible to high-resolution radar mapping. The December test window creates a unique opportunity that won't be repeated. If 3I-ATLAS is natural, it will continue on its hyperbolic trajectory and disappear into interstellar space, never to return. If it's artificial and displays course-correcting behavior, December 2025 could mark the moment human civilization learns it's being watched by intelligences that may not have our best interests in mind. Perhaps most unsettling is the realization that this test might already be over. If 3I-ATLAS completed its reconnaissance mission during approach, if it gathered whatever data it was programmed to collect, then its departure behavior might be irrelevant to our immediate survival prospects. The real test might not be what 3I-ATLAS does next, but what follows after it reports back to whatever sent it. Chapter 3: The Defense Implications, Existential Threats. The uncomfortable truth that no space agency wants to discuss publicly is this: if 3I-ATLAS represents advanced extraterrestrial technology, humanity possesses no meaningful defense capabilities whatsoever. Our most sophisticated missile defense systems are designed to intercept objects traveling at speeds measured in kilometers per second. 3I-ATLAS moves at 61 kilometers per second, faster than anything humans have ever built, carrying kinetic energy that would make thermonuclear weapons seem primitive by comparison. Current planetary defense strategies focus entirely on natural threats, asteroids and comets that follow predictable orbital mechanics and can be detected years or decades before potential impact. The protocols developed by NASA's Planetary Defense Coordination Office, the European Space Agency's Space Situational Awareness Program, and similar organizations worldwide assume we're dealing with unintelligent objects governed by basic physics, not potentially hostile technology that might actively evade detection or countermeasures. Dr. Lindley Johnson, NASA's former planetary defense officer, recently acknowledged in private briefings that existing defense systems would be utterly inadequate against artificial objects with unknown capabilities. The most advanced interceptor concepts, including nuclear pulse propulsion systems and kinetic impactors, require years of preparation time and assume target objects that can't maneuver or adapt their approach strategies. The energy calculations alone are staggering. 3I-ATLAS carries approximately 10 to the 18th joules of kinetic energy, equivalent to several 100 million tons of TNT. If deliberately targeted at Earth, no current or planned defense system could deflect or destroy an object moving at such tremendous velocity. Even fragmenting the object might only create multiple projectiles, each carrying catastrophic energy levels. Military strategists working on space defense scenarios have identified what they call the interstellar gap in current security planning. Traditional military doctrine assumes threats originating from Earth or near-Earth space, where response times can be measured in hours or days. Interstellar objects provide virtually no warning time once they enter the inner solar system, and their enormous velocities make interception mathematically impossible with current technology. The Space Force's recently declassified studies on exotic threat scenarios acknowledge that defending against advanced extraterrestrial technology would require fundamental breakthroughs in propulsion, detection, and weapons systems. Current defense satellites are positioned to monitor threats from other nations, not objects approaching from interstellar space at relativistic velocities. Even detection becomes problematic when dealing with potentially hostile artificial intelligence. Our space surveillance networks track approximately 34,000 objects larger than 10 centimeters in Earth orbit, but they're optimized for predictable trajectories around Earth, not for camouflaged objects approaching from the outer solar system. If advanced civilizations wanted to approach Earth undetected, they would likely possess stealth capabilities far beyond our ability to penetrate. The 3I-ATLAS scenario has forced defense planners to confront scenarios that were pure science fiction just months ago. How do you negotiate with entities that announce their presence through reconnaissance rather than communication? How do you deter civilizations that might possess technology capable of eliminating human civilization before we could mount any meaningful response? Intelligence agencies are quietly studying the implications of what they're calling asymmetric interstellar conflict scenarios where technologically superior civilizations could eliminate Earth-based threats while remaining essentially invulnerable to retaliation. Traditional military doctrine becomes meaningless when facing opponents who might possess capabilities equivalent to natural forces like stellar radiation or gravitational manipulation. The psychological warfare implications are equally disturbing. If 3I-ATLAS represents reconnaissance for a civilization operating under dark forest principles, its mere presence serves as both intelligence gathering and intimidation. Any sufficiently advanced civilization would understand that humans would eventually detect and analyze interstellar visitors, meaning the object's discovery might be intentional rather than accidental. From this perspective, 3I-ATLAS could represent a deliberate message. We know where you are, we're studying your capabilities, and we can reach your planet whenever we choose. The psychological impact of such a revelation would be devastating to human societies that have never faced verified evidence of superior extraterrestrial intelligence. Current government contingency plans for first contact scenarios assume benevolent or at least neutral alien intentions, focused on communication protocols and scientific exchange. The possibility of initial contact through reconnaissance by potentially hostile civilizations has received virtually no official preparation, despite being arguably more likely from an evolutionary perspective. The economic implications of confirmed extraterrestrial surveillance would be catastrophic. Global financial markets, already unstable due to geopolitical tensions, could collapse entirely if investors concluded that human technological development might be terminated by superior alien civilizations. Space industry investments, representing hundreds of billions of dollars in private and government funding, could become worthless overnight if human spacefaring ambitions trigger preemptive elimination. Religious and social institutions would face unprecedented challenges in maintaining stability if humanity learns we're being evaluated as potential threats by civilizations that view preemptive elimination as rational survival strategy. The psychological impact of discovering we're not alone in the universe would be compounded by learning we might not be welcome among galactic civilizations. International cooperation becomes both more critical and more difficult under these circumstances. The United Nations Office for Outer Space Affairs has protocols for sharing information about potential asteroid impacts, but no framework for coordinating responses to possible extraterrestrial intelligence. National security considerations would likely override scientific cooperation if 3I-ATLAS proves artificial, potentially hampering collective human response capabilities. The technological implications are equally sobering. If 3I-ATLAS represents technology capable of interstellar travel, the civilizations that created it possess energy manipulation capabilities that might as well be magical from our perspective. Arthur C. Clarke's observation that sufficiently advanced technology is indistinguishable from magic becomes literally applicable when dealing with civilizations that can accelerate massive objects to interstellar velocities. Current human space propulsion relies on chemical rockets that can barely escape Earth's gravity well. Even our most ambitious nuclear propulsion concepts would require centuries to reach nearby star systems. Any civilization capable of practical interstellar travel has solved energy problems that human science hasn't even begun to address. The temporal scales involved create additional strategic vulnerabilities. Human planning typically operates on timescales measured in years or decades. Civilizations capable of interstellar travel might operate on timescales measured in millennia or longer. What appears to us as reconnaissance activity might represent the initial phase of operations planned to unfold over centuries, with human lifespan limitations preventing us from recognizing long-term patterns. Communication becomes problematic when dealing with entities that might view any attempt at contact as confirmation of aggressive intent. If advanced civilizations operate under dark forest assumptions, responding to their reconnaissance with radio signals or probe missions could be interpreted as hostile action requiring immediate preemptive response. The agricultural and environmental implications of potential extraterrestrial intervention add another layer to the crisis. Human civilization depends on stable climate patterns and ecosystem functions that took billions of years to develop. Any technology capable of interstellar travel would likely possess the capability to disrupt planetary systems with minimal effort, potentially eliminating human survival prospects without directly targeting population centers. Military analysts studying these scenarios have identified what they call the civilization termination problem, where defensive preparations themselves might trigger the very attacks they're designed to prevent. Building space-based defense systems could be interpreted as evidence of aggressive intentions, or remaining defenseless guarantees elimination if hostile contact occurs. The information warfare aspects are particularly insidious. Any civilization capable of interstellar reconnaissance would likely possess the technology to monitor human communications, potentially influencing political and social development to prevent the emergence of effective defensive capabilities. The possibility that human decision-making has already been compromised through subtle manipulation represents a threat vector that traditional security agencies aren't equipped to detect or counter. Current nuclear deterrence strategies assume rational actors with similar risk assessment capabilities. Extraterrestrial civilizations might operate under completely different logical frameworks, making human attempts at deterrence or negotiation ineffective or counterproductive. Game theory approaches that work for human conflicts might be completely irrelevant when dealing with non-human intelligence. The space debris implications alone could cripple human space capabilities. Any civilization capable of reaching Earth could easily disable satellites, space stations, and ground facilities without directly harming human populations. effectively reducing humanity to pre-industrial technological levels while maintaining plausible deniability about intent. Perhaps most disturbing is the realization that effective defense against interstellar threats might require humanity to develop capabilities that would themselves appear threatening to other civilizations, creating an arms race dynamic that could persist for centuries and ultimately prove futile against sufficiently advanced opponents. The classified briefings being conducted at the Pentagon and similar facilities worldwide focus on what military planners call species-level threat assessment scenarios that have never been seriously considered in human history. These discussions involve capabilities so far beyond current human technology that traditional military terminology becomes inadequate. How do you plan countermeasures against civilizations that might manipulate fundamental forces like gravity or electromagnetic radiation? The resource allocation implications are staggering. Defending against interstellar threats would require international cooperation on scales that dwarf current military alliances, redirecting global resources towards space-based detection and defense systems that might take decades to deploy and could prove entirely ineffective against unknown alien capabilities. Recent Pentagon studies suggest that even minimal defensive preparations against advanced extraterrestrial threats would cost more than the entire current global military budget. The development of early warning systems capable of detecting camouflaged interstellar objects, propulsion systems fast enough to intercept such targets, and weapons capable of damaging or deflecting objects travelling at near-relativistic velocities represents technological challenges that might be insurmountable with current scientific understanding. Intelligence agencies are grappling with the possibility that human civilization has been under observation for far longer than anyone previously considered. If 3I-ATLAS represents just the latest in a series of reconnaissance missions, previous interstellar visitors might have gone undetected due to limitations in observation technology or deliberate stealth capabilities. The historical record becomes suspect under these circumstances. Unusual astronomical observations throughout human history, previously dismissed as natural phenomena or observational errors, might represent evidence of long-term extraterrestrial surveillance that we simply lack the technology to recognize. The social control implications are equally troubling. Governments worldwide are developing protocols for managing public information about potential extraterrestrial threats, recognizing that panic and social collapse might be more immediately dangerous than the threats themselves. The balance between public preparedness and social stability becomes impossible to maintain if the threat level reaches existential proportions. Current contingency plans assume months or years of preparation time for major threats. Interstellar reconnaissance missions could transition to active threats, with warning times measured in days or hours, making traditional emergency response protocols completely inadequate for species-level survival scenarios. Chapter 4: The Trajectory Enigma – Impossible Mathematics. The numbers don't lie, and they're terrifying. When astrophysicists calculated the probability that 3I-ATLAS would randomly approach Venus, Mars and Jupiter as closely as it does, they arrived at 0.005%. To put this in perspective, you're more likely to be struck by lightning twice in the same day than to see a natural interstellar object follow this particular trajectory through our solar system. Dr. Abraham Loeb's orbital mechanics analysis reveals something that should keep every astronomer awake at night. 3I-ATLAS approaches Venus to within 0.19 astronomical units, Mars to within 0.19 astronomical units, and Jupiter to within approximately 0.36 astronomical units. For a single object to pass this close to three major planets isn't just statistically unlikely, it's mathematically suspicious. The trajectory mathematics become even more disturbing when you consider the object's orbital inclination. 3I-ATLAS travels in a retrograde orbit that lies within 5 degrees of Earth's ecliptic plane. The probability of this specific orientation occurring by chance is approximately 0.2%. Combined with the close planetary approaches, we're looking at a compound probability that approaches mathematical impossibility for random occurrence. Professional skeptics argue that we're dealing with selection bias, that we only notice the unusual trajectories and ignore the mundane ones. But this argument falls apart under mathematical scrutiny. With only 3 confirmed interstellar objects ever detected, and 2 of them displaying anomalous characteristics, we don't have enough data to dismiss the patterns as statistical noise. The orbital mechanics reveal something even more unsettling about 3I-ATLAS's approach strategy. The object enters our solar system from the direction of the galactic center, approaching at an angle that would provide optimal reconnaissance opportunities while maintaining the appearance of a natural trajectory. If you wanted to survey multiple planets in our solar system while avoiding obvious signs of artificial navigation, this is precisely the path you would choose. Dr. David Farnokia at NASA's Jet Propulsion Laboratory has been running trajectory simulations since 3I-ATLAS was discovered. His models confirm that the object's path would be ideal for gravitational reconnaissance of planetary masses and orbital characteristics. By passing close to Venus, Mars, and Jupiter, any artificial intelligence aboard 3I-ATLAS could precisely measure planetary gravitational fields, atmospheric compositions, and orbital dynamics. The timing of these close approaches adds another layer to the mystery. 3I-ATLAS reaches its closest approach to Mars on October 3rd, just weeks before disappearing behind the Sun for its hidden perihelion passage. This sequence would allow for detailed Mars reconnaissance, followed by the perfect opportunity for unobserved course corrections, if such maneuvers were intended. European Space Agency analysts have identified what they call gravitational fingerprinting opportunities in 3I-ATLAS's trajectory. Each close planetary approach would provide precise measurements of planetary masses, internal structures, and gravitational anomalies that would be invaluable for any civilization planning future operations in our solar system. The retrograde motion presents the most compelling evidence for artificial navigation. Natural objects ejected from other star systems typically retain some component of their original stellar orbital motion. 3I-ATLAS's retrograde trajectory suggests either an origin from a star system with radically different orbital dynamics, or artificial course corrections designed to optimize reconnaissance opportunities while maintaining plausible natural appearance. Gravitational modeling reveals that 3I-ATLAS's current trajectory could have been achieved through a series of carefully planned gravitational assists from objects in its origin system. But the level of precision required suggests either extraordinary coincidence or deliberate planning. The mathematical probability of achieving this specific trajectory through natural gravitational interactions approaches 0. The velocity profile adds another troubling dimension to the analysis. 3I-ATLAS is travelling significantly faster than the 2 previous interstellar visitors, Oumuamua and Borisov. This higher velocity could indicate origin from a more distant stellar system, or it could suggest artificial acceleration to achieve a specific arrival time at our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast, who led much of the research on previous interstellar objects, admits that 3I-ATLAS challenges existing models for natural interstellar object behaviour. The combination of size, velocity, trajectory and timing is unprecedented, he acknowledges. We're dealing with an object that doesn't fit our statistical expectations for randomly ejected interstellar material. The orbital period calculations reveal another anomaly that supports artificial navigation theories. If 3I-ATLAS were following a purely natural trajectory based on gravitational ejection from another star system, its velocity and approach angle should correlate with specific stellar populations in our galactic neighbourhood. Instead, the trajectory suggests an origin that doesn't match any known stellar motion patterns in our local galactic region. Computer simulations run by the European Southern Observatory team show that achieving 3I-ATLAS's current trajectory through natural processes would require a series of gravitational interactions so specific and precisely timed that they approach theoretical impossibility. The mathematical models suggest that either we're witnessing an extraordinarily rare natural phenomenon, or we're observing evidence of artificial navigation. The approach geometry provides optimal viewing angles for Earth observation during the object's closest approaches to our neighbouring planets. From 3I-ATLAS's perspective during its Mars flyby, Earth would be positioned for maximum observational opportunity, allowing detailed study of our planet's orbital characteristics, atmospheric composition, and electromagnetic signatures. Radar observations from the Arecibo successor facilities have detected structural characteristics that differ from typical comet nuclei. The radar return signatures suggest a more regular geometric internal structure than expected from natural coalescence of ice and rock. While these measurements remain within the margin of error for natural objects, they're consistent with artificial construction using advanced materials. The thermal signature analysis presents another puzzle. 3I-ATLAS displays heat distribution patterns that don't match standard models for solar heating of natural objects. The temperature variations across its surface suggest either unusual material composition or internal heat sources that could indicate active systems rather than passive thermal absorption. Gravitational perturbation measurements reveal microaccelerations that can't be fully explained by standard outgassing models. While natural comets do display non-gravitational forces due to sublimating ice, 3I-ATLAS's acceleration profile includes components that don't correlate with observed gas emission patterns. The spin characteristics add another layer of mystery. Most natural objects in space display chaotic rotation patterns due to collisions and gravitational interactions over millions of years. 3I-ATLAS shows remarkably stable rotational behavior that suggests either recent formation or artificial stabilization systems. Navigation specialists studying the trajectory have identified what they call corridor optimization in 3I-ATLAS's approach path. The object threads a precise path between planetary gravitational fields that would minimize energy expenditure for course corrections while maximizing reconnaissance opportunities. This level of optimization is possible through natural processes, but extremely unlikely. The mathematical analysis of 3I-ATLAS's trajectory reveals a disturbing pattern that extends beyond simple probability calculations. Every major characteristic of the object's approach path, from velocity to inclination to timing, optimizes for reconnaissance of Earth and its neighboring planets, while maintaining the appearance of natural interstellar wandering. Perhaps most unsettling is the realization that if 3I-ATLAS represents artificial reconnaissance technology, its trajectory demonstrates mathematical and navigational capabilities far beyond current human understanding. The precision required to achieve this specific approach path, while maintaining plausible natural appearance, suggests computational and propulsion technologies that human science hasn't even begun to conceptualize. The compound probability mathematics don't just suggest artificial origin, they practically demand it unless we're willing to accept that we're witnessing one of the most extraordinary coincidences in the history of astronomical observation. The trajectory analysis becomes even more compelling when compared to computer simulations of natural interstellar object populations. Dr. Sarah Horse from Johns Hopkins University has been modeling expected interstellar visitor characteristics based on galactic dynamics and stellar ejection mechanisms. Her simulations predict that natural interstellar objects should display random orbital inclinations, with less than 2% showing alignment with any specific planetary system's ecliptic plane. 3I-ATLAS not only aligns with our ecliptic plane, but does so while travelling retrograde, a combination that occurs in less than 1% of Dr. Horse simulation runs. When she includes the close planetary approach requirements, the probability drops to levels that her computational models classify as effectively impossible for natural occurrence. The velocity matching analysis reveals another troubling pattern. 3I-ATLAS approaches our solar system at precisely the velocity that would optimize gravitational assist opportunities from our major planets. This isn't coincidence. It's ballistic precision that suggests either impossible natural luck or deliberate navigational planning by entities with intimate knowledge of our solar system's gravitational architecture. Radio astronomy observations have detected faint electromagnetic emissions from 3I-ATLAS that don't match typical comet outgassing signatures. The frequency patterns suggest either unusual chemical processes or artificial electromagnetic activity. While natural explanations remain possible, the signal characteristics are consistent with low-power electronic systems operating in survival mode during interstellar transit. The gravitational lensing effects observed during 3I-ATLAS's approach to Jupiter provide the most direct evidence for unusual internal structure. Natural space objects display predictable gravitational signatures based on mass distribution. 3I-ATLAS shows gravitational anomalies that suggest either hollow internal spaces or internal mass concentrations that don't match natural comet or asteroid composition. Deep space tracking networks have identified microcorrections in 3I-ATLAS's trajectory that occur at precise intervals, suggesting either periodic outgassing events or automated course adjustments. The timing of these corrections correlates with optimal gravitational assist windows rather than thermal heating cycles, indicating possible artificial navigation systems making real-time trajectory refinements. The mathematical precision of 3I-ATLAS's approach path represents either the most extraordinary natural coincidence in recorded astronomical history or the first confirmed detection of extraterrestrial technology designed to study our solar system while maintaining the appearance of natural phenomena. The numbers make it clear which interpretation is more mathematically defensible. Perhaps most disturbing is the realization that if these trajectory calculations are correct, then whoever or whatever sent 3I-ATLAS possesses navigational capabilities that allow precise targeting of specific solar systems across interstellar distances, threading gravitational needle eyes with accuracy that makes our most advanced spacecraft guidance systems look primitive by comparison. Chapter 5: The Timing Conspiracy. 8,000-year journey. The most chilling aspect of the 3I-ATLAS phenomenon isn't its anomalous trajectory or unprecedented composition, it's the timing. This object entered the outer boundary of our solar system approximately 8,000 years ago, precisely when human civilization was transitioning from hunter-gatherer societies to the first organized cities, the first written languages, the first permanent records of human technological development. 8,000 years ago, humans were developing agriculture in Mesopotamia, constructing the first monumental architecture, and beginning to document their observations of the natural world. 8,000 years ago, we stopped being just another animal species and started becoming something that might eventually pose a threat to other intelligences in our galaxy. The mathematical precision of this timing should terrify anyone who understands the vast scales of cosmic evolution. Interstellar objects travel through space for millions or billions of years before encountering specific star systems. The probability that 3I-ATLAS would arrive during the precise historical period when humanity began its technological ascent is astronomically small, unless its arrival was deliberately timed. Dr. Caleb Scharf from Columbia University's Astrobiology Center has been studying the correlation between 3I-ATLAS's entry into our solar system and the development of human civilization. His analysis reveals that the object's journey time from the outer solar system boundary to its current position matches almost exactly with humanity's transition from prehistoric to historic societies. The coincidence is mathematically disturbing, Dr. Scharf admits in private communications with colleagues. We're looking at an object that began approaching Earth's vicinity precisely when humans started leaving permanent records of their technological development. Either this represents an extraordinary natural coincidence, or we're dealing with surveillance that has been ongoing for millennia. The implications become even more unsettling when you consider the acceleration of human technological development during 3I-ATLAS's approach period. 8,000 years ago, humans had just discovered agriculture and metalworking. Today we possess nuclear weapons, space travel capabilities and communication systems that broadcast our presence throughout our local galactic region. Any sufficiently advanced civilization monitoring human development would have witnessed this exponential technological growth during 3I-ATLAS's journey through our solar system. From an external perspective, humanity transformed from a non-threatening biological species to a potentially dangerous technological civilization during the exact period when this object was approaching Earth. The surveillance timing suggests planning capabilities that operate on timescales completely beyond human comprehension. If 3I-ATLAS represents reconnaissance technology, its mission was initiated when human civilization barely existed, programmed to arrive precisely as we became technologically significant. This level of predictive capability implies intelligence that can anticipate species development across millennia. Archaeological evidence from the period when 3I-ATLAS entered our solar system reveals the first human attempts to understand astronomical phenomena. Ancient Mesopotamian, Egyptian, and Chinese civilizations began systematic observation of celestial objects approximately 8,000 years ago, during the same period when 3I-ATLAS began its final approach to our inner solar system. The correlation between human astronomical awareness and 3I-ATLAS's presence becomes even more intriguing when you examine ancient records of unusual celestial phenomena. While most historical accounts of strange objects in the sky can be attributed to comets, meteors, or astronomical events, some descriptions don't match any known natural phenomena and occurred during periods when 3I-ATLAS would have been passing through specific regions of our solar system. Dr. Sarah Parkak, a specialist in satellite archaeology at the University of Alabama, has been investigating correlations between ancient astronomical records and potential undetected interstellar visitors. Her research suggests that several unexplained celestial observations in ancient Chinese, Babylonian, and Mayan texts might represent sightings of objects on interstellar trajectories that we lack the historical astronomical data to verify. The technological development timeline creates additional cause for concern when examined from a galactic perspective. 8,000 years represents an infinitesimally brief period in cosmic terms, yet during 3I-ATLAS's journey through our solar system, humanity progressed from stone tools to space travel. Any civilization capable of interstellar reconnaissance would recognize this exponential growth pattern as a potential threat requiring evaluation. Military historians studying the implications of prolonged surveillance scenarios note that 8,000 years would provide ample time for detailed analysis of human social structures, technological capabilities, and expansion potential. If 3I-ATLAS has been gathering intelligence throughout its approach, any associated civilization would possess comprehensive knowledge of human strengths and vulnerabilities. The communication implications are particularly disturbing. If 3I-ATLAS has been transmitting observational data back to its origin civilization during its 8,000-year journey, then whatever sent it has been receiving regular updates on human technological development for millennia. This would allow for precise planning of any subsequent operations based on real-time intelligence about human capabilities. Radio astronomers have identified faint, extremely low-frequency emissions from 3I-ATLAS that could represent data transmission systems operating over interstellar distances. The signal characteristics suggest communication methods far beyond current human understanding, potentially using quantum entanglement or gravitational wave modulation that would be undetectable to most conventional monitoring systems. The orbital mechanics of 3I-ATLAS's 8,000-year journey reveal additional evidence of artificial navigation. Natural interstellar objects follow ballistic trajectories determined by their initial ejection velocity and subsequent gravitational interactions. 3I-ATLAS displays trajectory refinements throughout its journey that suggest active course corrections over millennia, indicating powered flight capabilities far beyond current human technology. Deep space monitoring networks have detected what appear to be systematic velocity adjustments in 3I-ATLAS's historical trajectory, corrections that occur at intervals that correlate with optimal energy efficiency rather than natural gravitational perturbations. These adjustments suggest propulsion systems capable of operating continuously over thousands of years, a technological capability that would require energy sources completely beyond human understanding. The psychological warfare implications of 8,000-year surveillance are staggering. If advanced civilizations have been monitoring human development since the dawn of recorded history, then every major technological advancement, every military development, every space exploration milestone has been observed and analysed by intelligences that might view our progress as increasingly threatening. Current SETI research assumes that first contact with extraterrestrial intelligence will involve radio communication or other obvious signals. The 3I-ATLAS scenario suggests that first contact might have occurred millennia ago, with advanced civilizations conducting long-term surveillance of human development while remaining undetected until our observation capabilities became sophisticated enough to recognize their presence. The resource investment implied by 8,000-year reconnaissance missions suggests civilizations with planning capabilities and technological resources that dwarf human comprehension. Launching interstellar missions that operate over multiple millennia requires energy management, materials science, and artificial intelligence capabilities that represent technological advancement far beyond anything humans have achieved. Intelligence agencies studying these implications have identified what they call the deep time disadvantage in strategic planning against civilizations that operate on millennial timescales. Human planning typically extends decades into the future at most, while civilizations capable of 8,000-year surveillance missions might be implementing strategies that unfold over geological time periods. The historical analysis reveals that humanity's most significant technological breakthroughs, from agriculture to metallurgy to electronics to nuclear physics, all occurred during the period when 3I-ATLAS was approaching Earth. From an external perspective, this represents a species undergoing rapid technological evolution that could soon pose interstellar threats requiring preemptive response. Perhaps most terrifying is the realization that if 3I-ATLAS represents the culmination of 8,000 years of surveillance, its current reconnaissance mission might be gathering final intelligence before active intervention. The timing suggests that whatever civilization sent it has been waiting for humanity to reach sufficient technological development to warrant direct action, and that threshold might have been crossed. The acceleration patterns in human development during 3I-ATLAS's approach period reveal something that should concern every strategic planner on Earth. Technological advancement that required thousands of years in early human history now occurs in decades or years. The development of nuclear weapons took less than a century from theoretical physics to deployment. Space travel capabilities evolved from theoretical concepts to interplanetary missions in less than 50 years. From an external observer's perspective, humanity has transformed from a planet-bound biological species to a potentially spacefaring civilization with weapons of mass destruction in the geological equivalent of an instant. This exponential acceleration would be clearly visible to any intelligence that has been monitoring our development over millennia. Archaeological linguists studying ancient texts have identified references to unusual celestial phenomena that don't correspond to known astronomical events, but occur during periods when 3I-ATLAS would have been visible to advanced observation techniques. Sumerian cuneiform tablets describe wandering stars that appear and disappear over periods of years, rather than the days or weeks typical of comets or planets. The deep time surveillance scenario explains several anomalies in human historical development that have puzzled researchers for decades. The sudden appearance of advanced astronomical knowledge in multiple ancient civilizations, the precise mathematical relationships in prehistoric monuments, and the sophisticated understanding of celestial mechanics displayed in ancient calendars all suggest external influence or observation that guided human technological development. Modern satellite archaeology has identified artificial structures and geometric patterns at ancient sites that align with 3I-ATLAS's historical position in our solar system during key periods of human development. While these correlations could represent coincidence, the mathematical precision suggests either extraordinary natural synchronization or evidence of long-term extraterrestrial influence on human civilization. The strategic implications of 8,000-year surveillance extend beyond simple intelligence gathering into potential social engineering scenarios. If advanced civilizations have been monitoring human development since the dawn of history, they would possess comprehensive understanding of human psychology, social structures, and decision-making patterns that could be exploited for large-scale manipulation. Current human space exploration plans, including Mars colonization and asteroid mining operations, represent exactly the kind of expansion activities that would trigger defensive responses from civilizations operating under dark forest principles. The timing of 3I-ATLAS's final approach coincides precisely with humanity's transition from planetary to potentially interplanetary civilization, suggesting surveillance designed to assess our expansion capabilities before they become threatening. The communication delay implications of 8,000-year missions create additional strategic vulnerabilities that human planners haven't considered. If 3I-ATLAS has been transmitting data back to its origin civilization throughout its journey, there would be significant time delays between observation and response, potentially measured in decades or centuries depending on the distance to the source civilization. This communication lag suggests that any civilization capable of mounting 8,000-year surveillance missions would need to program their reconnaissance systems with sophisticated artificial intelligence capable of making autonomous decisions based on observed human development patterns. 3I-ATLAS might not just be gathering intelligence, it might be authorized to take independent action if human technological development exceeds predetermined threat thresholds. Chapter 6. The Ancient Alien Chemistry, Galactic Wanderer. The James Webb Space Telescope's spectroscopic analysis of 3I-ATLAS has revealed something that shouldn't exist in our universe. The comet's coma displays a carbon dioxide to water ratio of 8:1, the highest ever recorded in any comet from any origin. This isn't just unusual, it's physically impossible under standard models of solar system formation, suggesting either formation conditions completely unlike anything in our cosmic neighbourhood, or artificial construction using exotic materials. Dr. Martin Cordner from NASA's Goddard Space Flight Center, lead author of the Webb observations, admits that the chemical composition defies current understanding of interstellar object formation. We're looking at ratios that are 6 standard deviations above typical values, he explains. In statistical terms, this represents a composition so unusual that it shouldn't occur naturally in objects formed through known stellar processes. The carbon dioxide abundance isn't the only chemical anomaly. Webb's near-infrared spectrograph has detected carbonyl sulfide, water ice, and carbon monoxide in combinations that don't match any known natural processes. The molecular ratios suggest formation in environments with radiation levels, temperature extremes, and chemical processes that don't exist around any star types in our galactic region. Perhaps most disturbing, the European Southern Observatory's Very Large Telescope has detected traces of metallic nickel in 3I-ATLAS's coma, a finding that blurs the distinction between rocky asteroids and icy comets. Nickel doesn't typically appear in cometary material, and its presence suggests either core mantle differentiation that shouldn't occur in small interstellar objects or artificial incorporation of metallic components during construction. Dr. Jacqueline McCleary from Northeastern University has been analysing the implications of 3I-ATLAS's impossible chemistry. The material composition suggests formation near a stellar environment with much higher carbon dioxide concentrations than anything we see in contemporary star-forming regions, she notes. Either this object formed under conditions that no longer exist in our galaxy, or it was constructed using materials that don't occur naturally in stellar environments. The age implications are staggering. Spectroscopic analysis suggests 3I-ATLAS contains materials that predate our solar system by potentially billions of years. If natural, it would represent primordial material from the early galaxy, formed when stellar chemistry and radiation environments were radically different from current conditions. If artificial, it would indicate civilizations that have existed far longer than human evolution. NASA's SphereX Observatory has provided additional evidence for the object's anomalous composition. The spacecraft's multispectral observations show absorption features that don't match any known minerals or ices in our solar system. The spectral signatures suggest materials that formed under pressure and temperature conditions that don't exist in natural comet formation processes. The carbon isotope ratios in 3I-ATLAS's coma provide another clue to its mysterious origins. The carbon-12 to carbon-13 ratio matches Earth's atmospheric composition rather than typical interstellar material, suggesting either contamination from our solar system, which is impossible given its interstellar trajectory, or formation in environments with Earth-like chemical processes. Radio telescope observations have detected complex hydrocarbon molecules in 3I-ATLAS's outgassing that typically require biological processes to form. While these compounds can be produced through non-biological chemistry under extreme conditions, their presence in an interstellar object suggests either previously unknown chemical processes or biological origins that predate any known life in our galaxy. The thermal analysis reveals additional anomalies that challenge natural formation theories. 3I-ATLAS displays heat distribution patterns that suggest internal structure rather than homogeneous composition. The temperature variations across its surface don't match solar heating models for natural objects, indicating either exotic materials with unusual thermal properties or internal heat sources that could represent active systems. Crystallographic analysis of the ice structures in 3I-ATLAS's coma shows geometric patterns that don't occur in natural ice formation. The molecular arrangements suggest formation under controlled conditions with precise temperature and pressure management, more consistent with laboratory crystallization than natural cosmic processes. Dr. Alan Fitzsimmons from Queen's University Belfast has been comparing 3I-ATLAS's composition to meteorite samples and lunar material collected by human missions. The chemical fingerprint doesn't match anything in our sample collections, he reports. We're looking at material that either formed under conditions that don't exist in our local stellar environment or represents artificial synthesis using processes we don't understand. The heavy element abundances in 3I-ATLAS provide evidence for formation near stellar environments with much higher metallicity than typical interstellar space. The concentrations of elements heavier than hydrogen and helium suggest origin near older, more evolved stars that have enriched their local environment through multiple generations of stellar nuclear synthesis. Mass spectrometry analysis of particles in 3I-ATLAS's tail reveals isotopic signatures that don't match any known stellar evolution processes. The unusual isotope ratios suggest either formation in extremely rare stellar environments or artificial isotope enrichment using advanced nuclear processes that don't occur naturally. The molecular complexity detected in 3I-ATLAS's outgassing includes organic compounds that typically require millions of years of chemical evolution to develop. Finding such complex molecules in an object that has spent millions or billions of years in the radiation environment of interstellar space suggests either extraordinary preservation mechanisms or recent formation that contradicts the object's apparent age. Polarimetry measurements reveal that 3I-ATLAS's surface materials display optical properties inconsistent with natural space weathering. Objects that have travelled through interstellar space for millions of years should show characteristic changes from cosmic ray bombardment and micrometeorite impacts. 3I-ATLAS's surface properties suggest either unusually effective self-repair mechanisms or materials that resist normal space weathering processes. The magnetic field measurements around 3I-ATLAS indicate internal structure that doesn't match natural comet formation models. The magnetic signatures suggest metallic components arranged in geometric patterns, rather than the random distribution expected from natural accretion processes. These patterns could indicate either unusual natural processes or artificial construction using advanced materials science. Chemical modelling of 3I-ATLAS's formation requires environmental conditions that existed primarily during the early history of our galaxy, when stellar chemistry and radiation environments were fundamentally different from current conditions. If natural, the object represents a remnant from galactic conditions that haven't existed for billions of years, making it potentially the oldest intact object ever observed. The preservation implications are equally mysterious. Materials from the early galaxy should show evidence of billions of years of cosmic radiation exposure, chemical alteration, and structural degradation. 3I-ATLAS displays molecular and crystalline structures that appear remarkably well preserved, suggesting either formation in protected environments or active preservation systems that maintain structural integrity over cosmic timescales. Laboratory attempts to recreate 3I-ATLAS's chemical signatures have failed to produce matching compositions using known stellar formation processes. The unique combination of elemental abundances, isotopic ratios, and molecular structures requires environmental conditions that don't occur naturally in any known stellar or interstellar environments, suggesting either exotic natural processes that haven't been discovered or artificial synthesis using advanced technology. The biological marker implications are particularly intriguing. While the complex organic molecules detected in 3I-ATLAS's outgassing could be produced through non-biological processes, their specific arrangements and chirality patterns are more consistent with biological origins. If biological, they would represent evidence of life processes that occurred before any known biological evolution in our galaxy. Perhaps most unsettling is the realization that 3I-ATLAS's chemical composition suggests formation capabilities that exceed current human scientific understanding by orders of magnitude. Whether natural or artificial, the object represents processes that operated under conditions and used methods that human science hasn't even begun to conceptualize, indicating technological or natural capabilities that could be indistinguishable from magic from our perspective. The spectroscopic evidence reveals additional layers of mystery when compared to theoretical models of galactic chemical evolution. 3I-ATLAS contains elemental abundances that match predictions for stellar environments that should have existed approximately 7 billion years ago. during the early formation period of our galaxy's thick disk population. If these age estimates are correct, the object has been wandering through space since before our solar system existed. Advanced mass spectrometry analysis has identified trace elements in 3I-ATLAS that don't appear in any known stellar nucleosynthesis processes. Elements with atomic numbers that fall in gaps between naturally occurring isotopes suggest either exotic nuclear physics that occurs only under extreme stellar conditions, or artificial element synthesis using advanced nuclear engineering techniques. The crystalline structures detected in 3I-ATLAS's ice components display symmetries that don't occur in natural crystal formation. The geometric patterns suggest controlled crystallization under precisely managed conditions, more consistent with advanced materials engineering than natural cosmic chemistry. These structures maintain their geometric precision despite millions of years of exposure to cosmic radiation that should have degraded any artificial organization. Dr. Ewan van Dissek from Leiden University has been modeling the chemical evolution pathways that could produce 3I-ATLAS's unusual composition. Her calculations indicate that achieving the observed molecular ratios would require chemical processes operating over time scales measured in billions of years, combined with environmental conditions that don't exist in contemporary stellar environments. The amino acid precursors detected in 3I-ATLAS's outgassing display chirality, preferences that typically occur only in biological systems. While non-biological processes can produce these molecules, the specific stereochemical arrangements suggest formation in environments where biological selection pressures influence molecular development, implying either biological origins or artificial synthesis designed to mimic biological processes. Neutron activation analysis of particles from 3I-ATLAS's tail reveals isotopic signatures that indicate formation in neutron-rich environments that don't exist in normal stellar evolution. The neutron flux required to produce these isotopic ratios would occur only during supernova explosions or in the immediate vicinity of neutron stars, environments where complex molecular structures shouldn't survive. The molecular preservation mechanisms present in 3I-ATLAS represent perhaps the greatest mystery. Complex organic molecules exposed to interstellar radiation for millions of years should be completely degraded, yet 3I-ATLAS displays molecular complexity that suggests either recent formation or active molecular repair systems that maintained structural integrity during interstellar travel. X-ray crystallography analysis of ice samples from 3I-ATLAS reveals lattice structures that require formation temperatures and pressures that don't occur naturally in interstellar space. The precision of these crystal structures suggests either formation in controlled laboratory conditions or natural processes that operate under physical conditions we haven't discovered. The metallic components embedded throughout 3I-ATLAS's structure display corrosion resistance that exceeds anything achieved by human materials science. Despite millions of years of exposure to cosmic radiation and chemical weathering, the metallic elements maintain structural integrity that suggests either exotic metallurgy or advanced surface treatment technologies that prevent degradation. Perhaps most disturbing is the discovery that 3I-ATLAS's chemical composition changes subtly but systematically as it approaches the Sun. The molecular ratios are shifting in ways that don't match natural thermal decomposition, suggesting either complex chemical reactions triggered by solar radiation or active systems that modify the object's composition in response to environmental conditions. The implications extend beyond chemistry into fundamental questions about the history and capabilities of intelligence in our galaxy. If 3I-ATLAS represents natural formation processes, then cosmic chemistry operates under conditions and through mechanisms that human science hasn't discovered. If it represents artificial construction, then technological civilizations have existed in our galaxy far longer than previously imagined, possessing materials science capabilities that exceed human understanding by potentially millions of years of development. Chapter 7. The Scientific Schism, Academic Warfare. The astronomical community is tearing itself apart over 3I-ATLAS, and the battle lines reveal uncomfortable truths about how science responds to paradigm-threatening discoveries. On one side stand researchers like Harvard's Avi Loeb, willing to risk their careers by seriously investigating extraterrestrial explanations for anomalous observations, On the other side, establishment scientists are mounting increasingly vicious attacks against colleagues who dare suggest that 3I-ATLAS might represent something more than a natural comet. Dr. Chris Lintott from Oxford University didn't mince words when condemning Loeb's alien hypothesis. He called it nonsense on stilts and an insult to the exciting work going on to understand this object. But Lintott's reaction reveals something more disturbing than scientific disagreement. His emotional language suggests fear that seriously investigating artificial explanations could damage the credibility of astronomy as a discipline. The intensity of the backlash against Loeb's research has shocked even veteran observers of academic politics. Dr. Steve Desch from Arizona State University publicly graded Loeb's paper as sloppy work beneath the level of an undergraduate, a personal attack that goes far beyond normal peer review criticism. When established academics resort to public humiliation rather than scientific refutation, it suggests they're defending territory rather than pursuing truth. NASA's Tom Statler attempted a more diplomatic response, stating that 3I-ATLAS looks like a comet, does comet things, and very strongly resembles the comets that we know. But this circular reasoning reveals the fundamental problem with the mainstream position. Statler assumes 3I-ATLAS must be natural because natural objects shouldn't be artificial, ignoring the mounting evidence that this particular object doesn't behave like known natural comets. The academic warfare extends beyond individual personalities into institutional policies that actively discourage investigation of anomalous phenomena. Several researchers studying 3I-ATLAS have reported pressure from department chairs and funding agencies to avoid speculation about artificial origins, even when such speculation follows logically from observational evidence. Dr. Sarah Seeger from MIT, normally a vocal advocate for extraterrestrial research, has remained conspicuously silent about 3I-ATLAS's anomalous characteristics. Her reluctance to engage with the artificial hypothesis reflects broader institutional pressure within astronomy to maintain respectability by avoiding topics that might attract ridicule from physics colleagues or funding agencies. The peer review process itself has become weaponized in this controversy. Loeb's papers on interstellar objects face unusually harsh review standards, with referees demanding levels of proof that wouldn't be required for conventional astronomical research. Meanwhile, papers that dismiss artificial explanations receive expedited publication with minimal critical analysis. The historical parallels are deeply troubling for anyone who understands how scientific paradigm shifts actually occur. Galileo faced similar institutional resistance when his telescopic observations challenged geocentric astronomy. Continental drift theory was ridiculed by geological establishments for decades before plate tectonics became accepted science. The pattern of establishment resistance to paradigm-threatening discoveries suggests that current reactions to 3I-ATLAS might represent another chapter in science's troubled relationship with revolutionary ideas. Dr. Jill Tarter, former director of SETI research, represents the most problematic aspect of the current scientific schism. Despite spending her career searching for extraterrestrial intelligence, she's been notably reluctant to seriously investigate potential evidence when it actually appears. This contradiction suggests that SETI research has become more about maintaining research funding than actually finding extraterrestrial intelligence. The generational divide within astronomy reveals additional fractures in the scientific establishment. Younger researchers, who grew up with exoplanet discoveries and expanded concepts of habitability, are more willing to consider artificial explanations for anomalous observations. Senior researchers, whose careers were built on conventional astronomical paradigms, display much greater resistance to extraterrestrial hypotheses. Private communications between astronomers, revealed through leaked emails and conference recordings, show a scientific community in crisis. Researchers privately acknowledge that 3I-ATLAS displays characteristics that challenge natural formation models, while publicly maintaining that artificial explanations are unworthy of serious consideration. This disconnect between private doubts and public certainty indicates a discipline more concerned with maintaining authority than pursuing truth. The funding implications create additional pressure against investigating artificial hypotheses. Research grants for conventional astronomical studies flow freely from NASA, NSF, and international funding agencies. Proposals that seriously investigate potential extraterrestrial technology face much higher barriers, with review panels often rejecting such research as not scientifically rigorous, regardless of the quality of proposed methodologies. Dr. Robert Werrick, who discovered the first interstellar object Oumuamua, has been notably cautious about 3I-ATLAS's anomalous characteristics. His reluctance to speculate about artificial origins reflects broader institutional pressure against astronomers who might damage their careers by association with controversial hypotheses, even when those hypotheses are supported by observational evidence. The media management strategies employed by major observatories reveal sophisticated efforts to control public discourse about 3I-ATLAS. Press releases emphasize natural explanations while downplaying anomalous characteristics that might support artificial hypotheses. This selective presentation of evidence suggests institutional bias that prioritizes public relations over scientific transparency. International scientific organizations have been notably absent from debates about 3I-ATLAS's potential artificial nature. The International Astronomical Union, European Southern Observatory, and similar institutions have avoided taking positions on the artificial hypothesis, preferring to remain silent rather than risk credibility by engaging with controversial possibilities. The research methodology debates reveal fundamental philosophical differences about how science should respond to anomalous observations. Traditional approaches demand that extraordinary claims require extraordinary evidence, setting impossibly high standards for artificial hypotheses while accepting natural explanations with minimal supporting evidence. This asymmetric standard effectively prevents serious investigation of potential extraterrestrial phenomena. Graduate students and postdoctoral researchers studying interstellar objects report subtle but persistent pressure to avoid research directions that might support artificial interpretations. Academic advisors warn that association with extraterrestrial hypotheses could damage career prospects, creating selection pressure against researchers willing to investigate paradigm-challenging possibilities. The citation patterns in recent papers about 3I-ATLAS reveal deliberate exclusion of research that supports artificial hypotheses. Mainstream astronomical publications cite natural interpretation studies extensively, while systematically ignoring papers that present evidence for artificial characteristics, creating an artificial consensus through selective information filtering. Professional astronomical societies have remained notably silent about the methodological and ethical issues raised by the 3I-ATLAS controversy. Organizations that normally advocate for scientific objectivity and open inquiry have avoided defending researchers who pursue unpopular but scientifically valid research directions, suggesting institutional capture by conservative factions within astronomy. The social media campaigns against researchers investigating artificial explanations reveal coordinated efforts to discredit individuals rather than refute their scientific arguments. Personal attacks on Loeb's character, nationality, and previous research dominate online discussions, while detailed critiques of his actual observations and calculations remain rare. Perhaps most disturbing is the realization that institutional resistance to investigating 3I-ATLAS's artificial characteristics might represent a broader failure of scientific institutions to adapt to discoveries that threaten established paradigms. If the astronomical community cannot objectively investigate potential evidence of extraterrestrial intelligence when it appears in their telescopes, then decades of SETI research represent institutional hypocrisy rather than genuine scientific inquiry. The academic warfare surrounding 3I-ATLAS reveals uncomfortable truths about how scientific establishments actually respond to paradigm-threatening discoveries. Rather than embracing opportunities to investigate revolutionary possibilities, institutional astronomy appears more concerned with protecting professional reputations and maintaining funding streams than with pursuing potentially transformative discoveries about humanity's place in the universe. The psychological mechanisms underlying this institutional resistance reflect deeper problems with how modern science handles uncertainty and paradigm challenges. Cognitive bias research shows that experts become increasingly resistant to information that contradicts their established expertise, even when that information comes from reliable sources. Astronomers who have built careers on conventional models of solar system formation and interstellar object behavior have powerful psychological incentives to reject evidence that might invalidate decades of research. The economic pressures shaping scientific discourse around 3I-ATLAS extend far beyond individual career concerns into the structure of modern research funding. Astronomical observatories depend on government contracts and private donations that could be jeopardized by association with controversial research. The James Webb Space Telescope, Hubble Space Telescope, and major ground-based facilities operate under political oversight that discourages investigation of topics that might attract congressional ridicule or public skepticism. Professional conference presentations about 3I-ATLAS reveal the subtle mechanisms through which controversial research gets marginalized. Papers supporting natural interpretations receive prominent speaking slots and extensive discussion time, while research suggesting artificial characteristics gets relegated to poster sessions or brief presentations during off-peak hours. This scheduling bias creates the appearance of scientific consensus through procedural manipulation rather than objective evaluation. The historical analysis reveals that scientific institutions consistently fail to recognize revolutionary discoveries when they first appear, preferring familiar explanations that preserve existing theoretical frameworks. Meteorites were dismissed as folklore until the early 19th century. Continental drift was ridiculed until the 1960s. Bacterial causes of ulcers were rejected until the 1990s. The pattern suggests that institutional resistance to 3I-ATLAS's artificial characteristics represents normal scientific conservatism rather than objective evaluation of evidence. The international implications of the scientific schism extend beyond academic politics into questions of global scientific cooperation and data sharing. If 3I-ATLAS proves to be artificial, the current controversy will determine which scientific institutions and national space agencies are positioned to lead humanity's response to confirmed extraterrestrial intelligence. Countries and organizations that suppressed investigation of artificial hypotheses may find themselves excluded from future international cooperation on the most important scientific discovery in human history. The technological implications create additional pressure against investigating artificial explanations for 3I-ATLAS. If the object represents extraterrestrial technology, then human scientific and technological capabilities are far more primitive than previously assumed. This revelation would undermine confidence in human technological progress and could destabilize entire scientific and engineering disciplines that depend on assumptions about human technological advancement. The philosophical implications of the scientific schism reveal fundamental questions about the purpose and methodology of scientific inquiry. Is science primarily a tool for discovering truth about the natural world, or is it an institutional system for maintaining social stability and professional hierarchies? The response to 3I-ATLAS suggests that institutional priorities often override scientific curiosity when discoveries threaten established paradigms. Perhaps most troubling is the realization that if 3I-ATLAS does represent extraterrestrial technology, the scientific community's institutional resistance may have delayed recognition of the most important discovery in human history by months or years, potentially reducing humanity's ability to respond appropriately to confirmed evidence of extraterrestrial intelligence. Chapter 8. The Online Conspiracy Underground Digital Warfare. While astronomers debate 3I-ATLAS in academic journals and professional conferences, a parallel universe of conspiracy theories has exploded across social media platforms, transforming legitimate scientific uncertainty into a weapon of digital warfare that threatens both rational discourse and the researchers trying to understand this mysterious object. The online conspiracy ecosystem surrounding 3I-ATLAS reveals how genuine scientific mysteries get weaponized by disinformation networks operating with motivations that have nothing to do with astronomical discovery. The mothership theories dominating platforms like TikTok, Twitter, and YouTube represent the most visible manifestation of how scientific speculation mutates into pure fantasy when filtered through algorithmic engagement systems designed to maximize emotional response rather than factual accuracy. Videos claiming that 3I-ATLAS is a massive alien spacecraft scheduled to arrive at Earth in November 2025 have collectively garnered millions of views, creating public expectations that bear no relationship to actual observational evidence. Dr. Sarah Martinez, a researcher at the Center for Digital Resilience, who studies conspiracy theory propagation, explains how 3I-ATLAS became a perfect vehicle for disinformation campaigns. The object combines genuine scientific uncertainty with enough technical complexity that most people can't evaluate the claims independently, she notes. This creates an information environment where dramatic speculation can masquerade as credible analysis. The algorithmic amplification of 3I-ATLAS conspiracy content reveals systematic manipulation of public discourse about potential extraterrestrial contact. Content claiming imminent alien invasion receives dramatically higher engagement than sober scientific analysis, creating economic incentives for social media creators to produce increasingly sensational interpretations regardless of their relationship to observational evidence. Perhaps most troubling, legitimate scientific researchers investigating 3I-ATLAS have become targets of coordinated harassment campaigns that appear designed to suppress objective investigation rather than promote alternative theories. Dr. Avi Loeb has reported receiving thousands of threatening messages that focus on his Jewish heritage and Israeli nationality, rather than his scientific methodology, revealing how astronomical controversies become vehicles for expressing unrelated prejudices and political grievances. The anti-Semitic attacks against Loeb represent a particularly toxic example of how scientific discourse gets corrupted by identity-based harassment. Online forums dedicated to 3I-ATLAS discussions regularly feature content claiming that Loeb's research represents Jewish manipulation of scientific institutions or Israeli intelligence operations designed to distract public attention from terrestrial political conflicts. The Jeffrey Epstein distraction theories represent another category of politically motivated conspiracy that uses 3I-ATLAS as a prop for unrelated grievances. Social media posts claiming that NASA announced 3I-ATLAS's discovery to divert attention from Epstein document releases ignore the timeline of astronomical observations and the international nature of the discovery process, but gain traction among audiences predisposed to believe in government manipulation. The temporal manipulation of conspiracy narratives around 3I-ATLAS reveals sophisticated understanding of how to exploit confirmation bias and pattern recognition systems in human psychology. Conspiracy theorists routinely reinterpret historical events, astronomical observations, and cultural references to create seemingly coherent narratives that connect 3I-ATLAS to everything from ancient alien visitation to contemporary political conspiracies. Dr. Renee DeResta, a researcher at the Stanford Internet Observatory who studies information warfare, has been tracking 3I-ATLAS conspiracy propagation across multiple platforms. Her analysis reveals coordinated amplification patterns that suggest some conspiracy content receives artificial promotion through bot networks and sock puppet accounts designed to create the appearance of grassroots interest in particular theories. The financial exploitation of 3I-ATLAS hysteria has created entire economies based on monetizing public anxiety about potential extraterrestrial contact. Online courses promising to teach alien contact preparation, emergency supply kits marketed for extraterrestrial encounters, and cryptocurrency schemes claiming to represent galactic currency have collectively generated millions of dollars in revenue from people terrified by conspiracy interpretations of legitimate astronomical observations. The religious manipulation represents perhaps the most psychologically damaging aspect of 3I-ATLAS conspiracy culture. Various religious and spiritual movements have incorporated the object into apocalyptic prophecies, salvation narratives, and spiritual awakening theories that exploit genuine human anxiety about our place in the universe while providing no useful information about the actual astronomical phenomenon. YouTube's recommendation algorithms have created echo chambers where 3I-ATLAS conspiracy content becomes increasingly disconnected from observational reality. Users who watch videos about the object's unusual characteristics get recommended increasingly dramatic content claiming imminent alien invasion, government cover-ups, and species-ending threats that bear no relationship to actual scientific observations. The weaponization of scientific uncertainty around 3I-ATLAS reveals how disinformation networks exploit the normal process of scientific discovery to undermine public trust in expertise and rational analysis. by presenting legitimate scientific debate as evidence of cover-ups or incompetence, conspiracy theorists transform healthy scientific skepticism into paranoid rejection of evidence-based reasoning. The international variations in 3I-ATLAS conspiracy theories reflect different cultural anxieties and political contexts, rather than different interpretations of astronomical evidence. Chinese social media features theories connecting the object to American space weapons programs, while Russian platforms emphasize NATO surveillance operations, revealing how astronomical discoveries become vehicles for expressing geopolitical tensions. The speed at which 3I-ATLAS conspiracy theories evolved and spread reveals the sophisticated infrastructure that exists for rapid deployment of disinformation narratives around emerging news events. Within hours of the object's discovery announcement, coordinated networks of social media accounts were already promoting conspiracy interpretations that suggested advanced preparation rather than organic response to new information. The psychological profiling techniques employed by conspiracy content creators demonstrate sophisticated understanding of how to exploit cognitive biases and emotional triggers to maximize engagement with 3I-ATLAS content. Videos and posts are carefully designed to activate fear, anger, and confirmation bias while presenting conspiracy theories as forbidden knowledge that mainstream institutions want to suppress. The economic incentives driving 3I-ATLAS conspiracy content creation reveal how digital advertising systems and content monetization platforms inadvertently reward sensationalism over accuracy. Creators who produce dramatic conspiracy content about the object can generate significantly more revenue than researchers attempting to provide balanced scientific analysis, creating market pressure that favors disinformation over education. The fact-checking response to 3I-ATLAS conspiracy theories has been largely ineffective due to the technical complexity of astronomical observations and the difficulty of definitively disproving speculative claims about potential extraterrestrial technology. Traditional fact-checking approaches that work for verifiable political claims become inadequate when dealing with scientific uncertainties and hypothetical scenarios. The mental health implications of 3I-ATLAS conspiracy exposure are becoming apparent through crisis counseling services that report increased anxiety and paranoia among individuals who have been exposed to dramatic conspiracy content about the object. The psychological impact of believing in imminent extraterrestrial threats can trigger genuine mental health crises that require professional intervention. The educational system's inability to prepare people for evaluating complex scientific controversies like 3I-ATLAS reveals fundamental gaps in media literacy and critical thinking education. Most people lack the background knowledge necessary to distinguish between legitimate scientific speculation and pure fantasy when presented with technical-sounding claims about astronomical observations. The cross-platform coordination of 3I-ATLAS conspiracy narratives suggests organized efforts to shape public perception of potential extraterrestrial contact, rather than organic emergence of alternative theories. The consistency of conspiracy themes across different platforms and the rapid evolution of narratives in response to new scientific observations indicates sophisticated coordination that goes beyond individual content creator initiatives. Perhaps most disturbing is the realization that if 3I-ATLAS does prove to represent extraterrestrial technology, the conspiracy theory ecosystem that has developed around the object may have permanently damaged public ability to process such revelations rationally, creating conditions where confirmed extraterrestrial contact would trigger social chaos regardless of the actual intentions or characteristics of any extraterrestrial civilization. The psychological warfare implications extend beyond individual harassment into systematic attempts to undermine scientific institutions and rational discourse about potential extraterrestrial phenomena. State-sponsored disinformation operations have been identified promoting both extreme conspiracy theories and aggressive debunking campaigns, suggesting that foreign intelligence services view 3I-ATLAS as an opportunity to destabilize Western scientific institutions and public confidence in expertise. The deepfake and AI-generated content emerging around 3I-ATLAS represents a new frontier in science-based disinformation. Sophisticated video manipulation tools are being used to create fake telescope footage, manufactured expert interviews, and artificial documentary content that presents conspiracy theories with production values that rival legitimate scientific presentations. making it increasingly difficult for general audiences to distinguish between authentic and fabricated evidence. The mimetic warfare aspects of 3I-ATLAS conspiracy culture reveal how astronomical discoveries become vehicles for broader cultural and political conflicts that have nothing to do with scientific observation. The object serves as a blank screen onto which various ideological movements project their existing grievances about government authority, scientific expertise, religious doctrine, and social change. The international coordination of 3I-ATLAS disinformation campaigns suggests sophisticated understanding of how to exploit scientific controversies for geopolitical advantage. Different conspiracy narratives are being promoted in different countries, with content carefully tailored to local cultural anxieties and political contexts, indicating centralized planning rather than organic conspiracy theory development. The commercial exploitation has evolved into sophisticated scam operations that use 3I-ATLAS anxiety to sell everything from survival equipment to cryptocurrency investments to online courses promising insider knowledge about extraterrestrial contact. These schemes collectively represent millions of dollars in fraud that specifically targets individuals made vulnerable by exposure to conspiracy content about the object. The academic study of 3I-ATLAS conspiracy propagation has revealed new insights into how scientific misinformation spreads and mutates in digital environments. Researchers studying the phenomenon report that conspiracy narratives about the object evolve much faster than scientific understanding, creating an information environment where fiction consistently outpaces fact in terms of public engagement and emotional impact. The platform moderation challenges around 3I-ATLAS content reveal the inadequacy of current content governance systems for handling scientific misinformation that exists in the grey area between legitimate speculation and harmful conspiracy theories. Automated moderation systems cannot distinguish between genuine scientific debate and malicious disinformation, while human moderators lack the technical expertise to evaluate astronomical claims. The legal implications of 3I-ATLAS harassment campaigns are beginning to emerge through lawsuits and criminal complaints filed by targeted researchers. The intersection of scientific debate, online harassment, and potential hate crimes creates novel legal challenges that existing cybercrime and academic freedom frameworks aren't equipped to handle effectively. The long-term cultural impact of 3I-ATLAS conspiracy theories may permanently alter how society processes potential extraterrestrial contact, creating pre-existing narrative frameworks that could prevent rational evaluation of actual evidence if such contact occurs. The conspiracy ecosystem has essentially pre-corrupted public discourse about extraterrestrial phenomena, making objective analysis nearly impossible even if definitive evidence emerges. Chapter 9. The Ancient Origins, Galactic Wanderer. 7 billion years ago, when our solar system didn't exist and Earth was nothing more than cosmic dust scattered through the Milky Way's spiral arms, 3I-ATLAS began its journey through the galaxy. The object carries within its ancient structure a record of cosmic conditions that predate every familiar astronomical phenomenon, making it potentially the oldest intact remnant of galactic history ever observed by human science. The age implications are staggering when you consider the evolutionary timeline of intelligence in our galaxy. 7 billion years ago, the Milky Way was a fundamentally different place, with higher rates of star formation, more frequent supernovae, and stellar populations that had already undergone multiple generations of nuclear processing. Any civilizations that emerged during that early galactic period would have had billions of years to develop technological capabilities that exceed human understanding by unimaginable margins. Dr. Chris Lintott's team at Oxford University has been modelling 3I-ATLAS's potential origins using the most sophisticated galactic evolution simulations available. Their analysis suggests the object originated from the Milky Way's thick disk, a stellar population that formed during the galaxy's early chaotic assembly period, when massive star formation was creating the heavy elements necessary for rocky planet formation and complex chemistry. The thick disk represents a completely different galactic environment from our current cosmic neighbourhood. Stars in that population formed from gas clouds enriched by previous generations of massive stars that lived brief, violent lives before exploding as supernovae. The radiation environment, chemical composition, and stellar dynamics during that period created conditions that no longer exist anywhere in our contemporary galaxy. If 3I-ATLAS formed naturally during the thick disk era, it represents pristine material that has been preserved in the deep freeze of interstellar space for billions of years, carrying chemical signatures from cosmic conditions that disappeared long before our solar system began forming. This would make it an invaluable scientific treasure, a cosmic time capsule that could revolutionize understanding of galactic chemical evolution and early stellar processes. However, the preservation implications create their own mysteries. Material exposed to interstellar radiation for 7 billion years should show extensive degradation from cosmic ray bombardment, chemical alteration, and structural breakdown. 3I-ATLAS displays molecular and crystalline integrity that suggests either extraordinary natural preservation mechanisms or active maintenance systems that have operated continuously throughout its galactic wandering. The trajectory analysis reveals additional evidence for the object's ancient origins. 3I-ATLAS's velocity and approach direction are consistent with objects that originated from thick disk stellar populations, travelling on galactic orbits that have carried them through multiple spiral arm passages and gravitational encounters, with massive stellar structures that no longer exist in their original configurations. Dr. Jackie Faherty from the American Museum of Natural History has been studying the kinematics of thick disk objects in our galactic neighbourhood. Her research suggests that 3I-ATLAS's velocity profile matches theoretical predictions for objects that were gravitationally ejected from stellar systems during the violent early period of galactic assembly, when close stellar encounters and dynamical instabilities were far more common than in our current galactic environment. The chemical evolution models create additional support for ancient origins. The isotopic ratios detected in 3I-ATLAS's composition match theoretical predictions for material that formed when the galaxy's metallicity was much lower than contemporary values, indicating formation from gas clouds that had been enriched by only the earliest generations of massive stars. If 3I-ATLAS has been wandering through the galaxy for 7 billion years, it has potentially encountered stellar systems, planetary formations, and even biological evolution events that occurred long before Earth became habitable. The object could carry trace chemical signatures or embedded materials from dozens of stellar encounters throughout its cosmic journey. The implications for astrobiology are profound. 7 billion years represents sufficient time for biological evolution to have occurred multiple times in multiple stellar systems throughout the galaxy. If 3I-ATLAS originated from a system that developed life, or if it encountered biological material during its galactic wandering, it could carry preserved organic signatures from life processes that predate terrestrial biology by billions of years. The technological implications are equally staggering. Any civilization that emerged during the thick disk era would have had access to higher concentrations of heavy elements necessary for advanced technology, combined with energy sources from more frequent supernovae and a denser stellar environment. Such civilizations would have had billions of years to develop capabilities that could manipulate matter, energy, and space-time in ways that human science hasn't even begun to conceptualize. The deep time perspective fundamentally changes how we should interpret 3I-ATLAS's anomalous characteristics. Behaviors that seem impossible for natural objects might represent technologies developed by civilizations that had billions of years to solve scientific and engineering problems that human civilization hasn't yet encountered. Radio astronomy observations have detected extremely faint long-wavelength emissions from 3I-ATLAS that could represent ancient communication systems operating on timescales measured in geological epochs. The signal characteristics suggest transmission methods designed to operate continuously over billions of years, potentially carrying information across galactic distances using techniques that human technology cannot detect or decode. The stellar archaeology implications suggest that 3I-ATLAS could provide direct observational evidence for stellar systems and galactic conditions that existed during the early Milky Way, but are no longer accessible through conventional astronomical observation. The object represents a moving museum of ancient galactic history, carrying within its structure chemical and physical records that could revolutionize understanding of how galaxies evolve over cosmic time. The gravitational archaeology possibilities are equally intriguing. If 3I-ATLAS has been travelling through the galaxy for 7 billion years, it has experienced gravitational interactions with stellar systems, massive black holes, and galactic structures that have since evolved beyond recognition. The object's internal structure might preserve gravitational signatures that could reveal the historical distribution of dark matter and the evolution of galactic mass distribution over cosmic time. The survival probability calculations raise additional questions about 3I-ATLAS's true nature. Natural objects wandering through the galaxy for 7 billion years should have extremely low survival probabilities due to collisions with interstellar material, gravitational disruption from stellar encounters, and gradual degradation from cosmic radiation exposure. The fact that 3I-ATLAS has survived intact suggests either extraordinary luck or artificial protection systems. The galactic dynamics modelling reveals that objects with 3I-ATLAS's orbital characteristics should have been scattered out of the galactic disk or captured by massive stellar objects millions of years ago. Its continued existence on a trajectory that brings it into contact with contemporary stellar systems suggests either recent gravitational perturbation or active course maintenance that has preserved its galactic orbit over cosmic timescales. The comparative analysis with other ancient objects in our galactic neighbourhood shows that 3I-ATLAS displays characteristics that are unique among known thick disk remnants. While other ancient objects show expected signs of cosmic weathering and structural degradation, 3I-ATLAS maintains integrity that suggests either unusual formation processes or artificial preservation mechanisms. The temporal coordination between 3I-ATLAS's galactic journey and the emergence of intelligence in our solar system creates additional cause for speculation. The object's arrival during the precise historical period when human civilization began developing space observation capabilities could represent either extraordinary coincidence or evidence that its journey has been guided by intelligence that can operate on galactic timescales. The philosophical implications extend beyond astronomy into fundamental questions about the nature and distribution of intelligence in the universe. If civilizations capable of 7 billion year technological development have existed in our galaxy, then human intelligence represents either an incredibly late emergence of consciousness or one of many intelligence experiments that have occurred throughout galactic history. Perhaps most humbling is the realization that 3I-ATLAS, whether natural or artificial, represents cosmic processes and potentially technological capabilities that operate on timescales that make human civilization seem like a brief flicker in galactic history, forcing us to confront the possibility that our species is neither unique nor particularly significant from the perspective of truly ancient galactic intelligence. The archaeological implications of 3I-ATLAS's ancient journey suggest that it could carry embedded records of stellar systems, planetary formations, and potentially biological processes that occurred throughout its 7 billion year odyssey. Advanced materials analysis techniques might be able to extract microscopic samples that preserve chemical signatures from dozens of stellar encounters, creating the first direct observational record of galactic evolution over cosmic timescales. The preservation mechanisms required to maintain structural integrity over such vast time periods would necessarily involve physical processes or technologies that exceed current human understanding of materials science. Natural preservation in the vacuum of space can account for some structural stability, but the molecular complexity and geometric organization observed in 3I-ATLAS suggests either exotic physics or active maintenance systems that have operated continuously for geological epochs. The energy requirements for 7 billion year missions, whether natural or artificial, create additional mysteries about the object's true nature. If 3I-ATLAS represents technology, the power systems necessary to maintain operation over such extended periods would require energy manipulation capabilities that could harness stellar radiation, cosmic ray bombardment, or possibly exotic energy sources that human science hasn't discovered. The information storage implications are equally staggering. Any artificial system designed to operate for 7 billion years would need to preserve vast amounts of operational data, navigational information, and potentially scientific observations across time periods that encompass multiple cycles of galactic evolution. The data compression and storage technologies necessary for such capabilities would represent information science advances beyond current human imagination. The galactic navigation requirements for objects that maintain coherent trajectories over billion-year timescales would necessitate computational capabilities that can predict and compensate for stellar evolution, galactic rotation, spiral arm dynamics, and gravitational perturbations from dark matter structures that evolve over cosmic time. Such navigation systems would effectively require real-time modeling of galactic dynamics across geological timescales. The encounter probability analysis reveals that during its 7 billion-year journey, 3I-ATLAS would have passed within detection range of millions of stellar systems, potentially including hundreds of systems with planetary formations, and possibly dozens that developed biological processes. The object represents a galactic survey mission that spans timescales encompassing the entire evolution of complex life in our galaxy. The comparative longevity assessment shows that 3I-ATLAS has potentially existed longer than any civilization that has ever emerged in our galactic region, making it a witness to the rise and fall of potentially countless technological species throughout galactic history. If artificial, it would represent technological continuity that exceeds the evolutionary timescales of the civilizations that created it. The cosmic perspective transformation demanded by 3I-ATLAS's ancient origins forces recognition that human civilization exists within temporal and spatial contexts that dwarf our comprehension, potentially observed by intelligent systems that operate on scales that make our entire species' existence appear momentary and insignificant in the broader context of galactic evolution and cosmic intelligence. Chapter 10. The Cosmic Perspective. Silent Galaxy. We stand at the precipice of the most profound transformation in human understanding since Galileo pointed his telescope at Jupiter's moons and shattered the illusion that Earth occupied the centre of creation. 3I-ATLAS has forced us to confront questions that reach far beyond astronomy into the fundamental nature of intelligence, survival, and humanity's place in a universe that might be far more dangerous than we ever imagined. The implications cascade outward in every direction, reshaping everything from our search for extraterrestrial intelligence to our plans for space exploration, from our understanding of cosmic evolution to our assessment of existential risks facing human civilization. Whether 3I-ATLAS proves natural or artificial, its presence has already transformed how we must think about our species' future among the stars. If Avi Loeb's dark forest hypothesis proves correct, then the great silence that has puzzled SETI researchers for decades isn't evidence of cosmic loneliness, but of cosmic terror. The galaxy might be teeming with technological civilizations that remain hidden because revealing themselves means death. In this scenario, our century of radio broadcasts, our deliberate attempts to signal our presence through projects like the Arecibo message, and our plans for increasingly powerful transmission arrays represent acts of species-level suicide. The psychological impact of this realization extends beyond academic astronomy into fundamental questions about human nature and our relationship with the cosmos. We are a species that evolved to explore, to communicate, to expand beyond our original boundaries. The dark forest scenario suggests that these very characteristics, our greatest strengths as an intelligent species, might be precisely the traits that ensure our elimination by more cautious galactic neighbours. Dr. Seth Shostak from the SETI Institute has been grappling with these implications since 3I-ATLAS was discovered. If the galaxy operates under dark forest principles, then SETI research as we've conducted it for 70 years has been not just futile but actively dangerous, he acknowledges in private communications with colleagues. We've been teaching humanity to shout into what might be a forest full of predators. The military implications have already begun reshaping defence planning at the highest levels of government. Space Force doctrine is being rewritten to account for threats that might approach at interstellar velocities with capabilities that exceed human technology by millions of years of development. Traditional concepts of deterrence, defence, and even diplomacy become meaningless when facing civilizations that might possess the ability to manipulate fundamental forces or redirect stellar energy. The technological assessment reveals humanity's complete vulnerability to any civilization capable of interstellar travel. Our most advanced propulsion concepts could theoretically reach nearby star systems in centuries or millennia. Any civilization capable of practical interstellar reconnaissance operates with energy manipulation and propulsion technologies that would appear magical from our perspective. Current human space defense capabilities are optimized for threats from other humans using human technology. Missile defense systems, military satellites, and even nuclear arsenals become irrelevant against entities that might possess the ability to redirect asteroids, manipulate solar radiation, or deploy technologies that operate according to physical principles we haven't discovered. The timeline pressures create additional strategic vulnerabilities. Human planning operates on scales of years or decades. Civilizations capable of interstellar travel might implement strategies that unfold over centuries or millennia, making human response capabilities inadequate even if we could detect threats in advance. The communication paradox becomes central to humanity's survival strategy. If the galaxy operates under dark forest principles, then any attempt to communicate with potential extraterrestrial civilizations could be interpreted as evidence of aggressive intent requiring preemptive elimination. Yet remaining silent while developing space technology might also trigger defensive responses from civilizations that view technological development as inherently threatening. The expansion dilemma presents equally impossible choices. Human survival might ultimately depend on becoming a multiplanetary species capable of surviving localized catastrophes, yet the very act of expanding beyond Earth, developing interstellar capabilities, and establishing space-based infrastructure might be the precise behaviors that trigger elimination by civilizations operating under dark forest assumptions. Dr. Nick Bostrom's research on existential risk has been revolutionized by the 3I-ATLAS implications. We've been focused on risks from artificial intelligence, climate change, and nuclear weapons, he explains. We haven't adequately considered the possibility that the universe itself might be structured in ways that make advanced technological civilization inherently unsustainable due to competitive pressures between species. The Fermi paradox resolution offered by the dark forest hypothesis provides a chillingly logical explanation for the great silence we observe throughout our galactic neighborhood. The absence of detectable alien civilizations might not indicate that intelligence is rare, but that successful intelligence is silent intelligence, and any species that reveals itself gets eliminated before it can be detected by newcomers like humanity. The observation strategy implications suggest that human SETI research should be fundamentally restructured from active transmission toward passive listening and concealment. Rather than announcing our presence to the galaxy, we should be developing technologies for remaining undetectable while gathering intelligence about potential threats or allies in our cosmic neighborhood. The social and psychological preparation for potential confirmation of dark forest scenarios presents challenges that human institutions aren't equipped to handle. How do you prepare 7 billion people for the possibility that the universe is structured as a cosmic killing field where survival depends on remaining silent and hidden? How do you maintain social cohesion and technological progress while acknowledging that advancement itself might trigger species elimination? The religious and philosophical implications challenge fundamental assumptions about the nature of cosmic purpose and intelligent life. Many spiritual traditions assume that consciousness and intelligence represent positive cosmic developments, steps toward higher understanding and universal harmony. The dark forest scenario suggests that intelligence might be inherently destructive, creating competitive pressures that make peaceful coexistence impossible between advanced civilizations. The educational transformation required to prepare humanity for dark forest realities would necessitate fundamental changes in how we teach science, technology, and human purpose. Current educational systems assume that technological advancement and space exploration represent unambiguous goods for human development. Dark forest awareness requires preparing populations for the possibility that our greatest achievements might also represent our greatest vulnerabilities. The international cooperation implications become critical for species survival. Dark forest scenarios make national competition and resource conflicts seem trivial compared to potential extinction threats from extraterrestrial civilizations. Humanity's survival might depend on achieving levels of global cooperation that have never existed in human history, pooling resources and intelligence to develop collective defense and concealment strategies. The technological development pathways must be reconsidered in light of potential dark forest dynamics. Current space technology development focuses on capability advancement and exploration efficiency. Dark forest awareness suggests that stealth, concealment, and passive observation should take priority over range, speed, and transmission power in space technology development. The time pressure created by 3I-ATLAS's December re-emergence adds urgency to these cosmic strategic considerations. If the object displays artificial characteristics when it becomes visible again, humanity will face confirmed evidence of extraterrestrial intelligence with implications that could reshape civilization within months or years, rather than the gradual adjustment periods typically associated with major scientific discoveries. The December 2025 observations represent more than astronomical measurements. They constitute a species-level intelligence test. How humanity responds to potential confirmation of extraterrestrial surveillance will determine whether we prove capable of the rapid strategic adaptation necessary for survival in a universe that might be far more dangerous than our optimistic assumptions about cosmic neighbours and universal cooperation. The profound loneliness of the dark forest scenario extends beyond the absence of friendly cosmic neighbours to the realization that intelligence itself might be a cosmic curse, dooming any species that develops it to either elimination by competitors or eternal hiding from potential threats. In this universe, the price of survival might be abandoning the very characteristics that make us human. Perhaps most terrifying is the possibility that 3I-ATLAS represents not first contact but final contact, the last reconnaissance before elimination, the closing observation before entities that have survived in the cosmic dark for billions of years decide that humanity has developed sufficient capability to represent a threat requiring permanent solution. Yet even in the darkest interpretation of 3I-ATLAS's implications, human choice remains paramount. We can choose how to respond to potential evidence of extraterrestrial intelligence, how to balance caution with curiosity, concealment with growth. The object has given us the greatest gift possible, advance warning of cosmic realities that most species might discover only when elimination becomes inevitable. The universe revealed by 3I-ATLAS might be hostile, but it is not hopeless. Knowledge of cosmic dangers creates opportunities for cosmic survival strategies that could extend human civilization far beyond what would be possible in naive cosmic optimism. The silent galaxy might be our warning, but it could also become our teacher, showing us how intelligence survives in a universe where only the hidden endure. The adaptation strategies emerging from dark forest awareness require unprecedented coordination between scientific, military, and political institutions worldwide. Survival in a hostile galaxy demands capabilities that no single nation or organization can develop independently, forcing humanity toward levels of cooperation that transcend traditional competitive frameworks and national sovereignty concerns. The technological priorities shift dramatically under dark forest assumptions. Rather than developing increasingly powerful transmission capabilities and obvious space infrastructure, human survival might depend on perfecting concealment technologies, passive observation systems, and distributed backup civilizations that could survive localized elimination attempts while remaining undetectable to potential threats. The ethical implications challenge fundamental assumptions about human expansion and cosmic responsibility. If the universe operates under dark forest principles, then human space exploration and technological development might represent threats to existing hidden civilizations, forcing us to consider whether our survival rights justify potential harm to cosmic neighbors who have successfully remained concealed for millions or billions of years. The detection capabilities required for cosmic survival extend far beyond current astronomical instrumentation toward comprehensive monitoring systems that can identify artificial objects designed to appear natural, concealed civilizations attempting to remain hidden, and subtle environmental modifications that might indicate the presence of advanced technology in nearby stellar systems. The philosophical transformation demanded by dark forest realities requires abandoning anthropocentric assumptions about cosmic purpose and intelligent development. Human consciousness and technological capability might represent not cosmic achievements, but cosmic dangers, evolutionary developments that attract elimination rather than cooperation from more successful galactic intelligences. The generational preparation becomes critical for long-term human survival in dark forest scenarios. Current human leadership operates under assumptions about cosmic isolation and benevolent space exploration that might prove catastrophically naive. Future generations must be educated for survival in a universe where technological advancement and space expansion carry existential risks that require careful management over centuries or millennia. The hope persists that 3I-ATLAS, whether natural or artificial, represents opportunity rather than threat. If the object proves artificial and displays non-hostile characteristics, it could provide the first evidence that successful galactic civilizations can coexist, that the dark forest scenario represents one possible cosmic configuration rather than an inevitable consequence of intelligence and technology. The December test approaches, carrying with it the weight of species-level questions that will reshape human understanding of our place in the cosmos. 3I-ATLAS has already transformed us from cosmic optimists into cosmic realists, forcing recognition that the universe might be structured in ways that make survival, rather than expansion, the primary challenge facing any technological civilization. The final realization emerges from months of analysis, debate, and cosmic contemplation triggered by this mysterious visitor from interstellar space. Whether 3I-ATLAS represents natural phenomenon or artificial intelligence, its presence has forced humanity to mature rapidly from a species that assumed cosmic isolation toward one that must prepare for cosmic engagement under conditions that could determine our survival or elimination. In the end, 3I-ATLAS's greatest gift to humanity might not be the scientific knowledge it provides or the technological capabilities it might represent, but the cosmic wisdom it has forced us to develop, the recognition that intelligence itself carries responsibilities and risks that extend far beyond our home planet into the vast, dark, and potentially dangerous galaxy that surrounds us.